Hello, and welcome to the Junior 2 Version 2 Medication Calculation Practice Questions. Please follow the guidelines below, numbers 1 through 6, as we answer questions 1 through 3. So for number 1, we have the order of 1,000 mLs of D5W over 12 hours. Calculate the drops, or GTTS, per minute using a macro drip IV set. Macro drip means that it's going to be bigger drops. And the rate for a macro drip is going to be 10 drops per 1 ml. So let's go ahead, and we are trying to find the units of drops per minute. Our order is 1,000 mLs over 12 hours, and what we have available is 10 drops per ml. And we also need to know that there are 60 minutes in 1 hour. So using the equation, order times available, we have 1,000 mLs over 12 hours, and we want to cancel the units of ml so that we're left with drops per hour. And also we want to go ahead and cancel the units of hour. So we're going to put 1 hour in the numerator, 60 minutes in the denominator. And as you can see, ml units cancel, hour units cancel, and you're left with drops per minute. So let's go ahead and do the math. 1,000 times 10 is 10,000. And we have 12 times 60, 720. So 10,000 divided by 720 is 13.9 mLs. Oops, excuse me. 13.9 drops per minute. And you can actually round this to 14 drops per minute as your final answer. 1B, calculate the drops per minute using a micro drip IV set. So micro drip means that there's going to be more drops per ml. So the micro drip rate is going to be 60 drops per 1 ml. And the units that we want to end up with are drips per minute. So as you can see, it's going to be very similar as what we did in 1A, except our drip rate is going to be 60 drops per ml instead of 10 drops per ml. So let's go ahead and put our equation in. So 1,000 mLs per 12 hours, we have 60 now per ml. Our ml units will cancel. 1 hour on the numerator, so our hour units cancel. 60 minutes in the denominator, so we're left with 60. So we're left with drops per minute. So what we have here is the answer of 83.3 drops per minute, or you can just round it to 83 drops per minute. Final answer for 1B. Number 2 is based on the order for Lasix, 130 milligrams IV stat. The drug available is Lasix 10 milligrams per ml. The IV infusion is not to exceed 40 milligrams per ml. 2A is asking for how many mLs of the drug would you give? So let's go ahead, and our final units that we're looking for are mLs. So the order is 130. What's available is 10 milligrams per ml. Order times available is 130 milligrams. You want to cancel out the units of milligrams. So you want 10 milligrams in the denominator, mLs in the numerator, and you'll get 130 divided by 10 is 13 mLs for 2A. So final answer for 2A is 13 mLs. For 2B, it's actually a continuation. So it's asking you over how many minutes would you administer the medication by IV push? So let's go ahead, and I'm gonna go ahead and clear it so I can fix the window. There you go. So let's see. Over how many minutes would you administer the medication? So your final units are gonna be in minutes. Your order is 130. What's available is 40 milligrams per minute. So you're going to do order times available, 130 milligrams. You want to cancel the units of milligrams, so you put 40 milligrams on the bottom. $130 divided by 40 is 3.25 minutes. So final answer for 2B is 3.25 minutes. 2C is now asking over how many seconds would you administer the medication by IV push? And so this is our answer for 2B down here. And so we're left with 3.25 minutes. So you're gonna, well, your units that you're looking for are in seconds. Your order is 3.25 minutes. What you have available is 60 seconds in 1 minute, 3.25 minutes. You want to cancel your minutes unit. So 3.25 times 60 is 195 seconds. Final answer for 2C, 195 seconds. Number 3, the physician requires a continuous heparin infusion drip at 12 units per kilogram of body weight per hour. The patient weighs 90 kilograms. The available solution contains 20,000 units heparin per liter of D5W. How many mLs per hour will the nurse program the IV infusion pump to run? So our final units that we're looking for are mLs per hour. And let's break down the question a little bit more. So the units that we want to end up are mils per hour. What the physician ordered is 12 units per kilogram per 1 hour. What we have available is the patient's weight at 90 kilograms. And we also know that what's available is 20,000 units of heparin per 1 liter of D5W. So let's go ahead and figure out, we have in our order 3 units. We have units, kilogram, and hour. let's go ahead and get rid of the kilograms by multiplying this order by the patient's weight of 90 kilos. So we have order times available, 12 units per kilogram all over 1 hour. And you're going to multiply that by 90 kilograms of the patient's weight. Cancel out the kilograms, and you get 12 times 90 equals 1080 units per 1 hour. And we also know that there is 20,000 units per 1 liter available. So we're going to take that and we're going to cancel out the unit of units. So you want 1 liter on the numerator, 20,000 units in the denominator. Cancel out the units and you're left with liters per hour. So 1080 divided by 20,000 is 0.054 liters per hour. And you have to know this conversion in 1 liter, there's 1,000 mLs. So knowing that, take your 0.054 liters per hour. You want to cancel out the units of liters and keep 1,000 mLs in the numerator, and you get 54 mLs per hour as your final answer for number 3. 54 mLs per hour.